Hey, good morning, students. Today we're going to be talking about solving radical equations. Those are the equations that contain square roots. They can come up in a variety of ways. We'll later in the week talk about some applications of them. But as far as solving radical equations go, there's several things you need to keep in mind. One, you always want to isolate the radical, and then we'll undo the radical with a square and go from there. Sometimes, obviously, if you're squaring things, you can end up with some quadratics, and so you'll need to have your quadratic formula in your tool belt and ready to use. You will also have what we call extraneous solutions sometimes. Sometimes with those quadratics, you may get two solutions, but not always will both of them work. So be ready to test those solutions to find out if they are indeed valid solutions to the equation. And also, sometimes you can end up with multiple radicals in a single equation. So we'll look at a problem like that as well. So let's get started and we'll see what we can discover about radical equations and solving them. All right, if we look at our first example here, we'll say example 1. And we want to solve a very simple radical equation, and that would just be the square root of x is equal to 12. Okay? This is a very simple problem, but some of you may look at that and you're like, I'm not sure how to do that. Well, let me show you. As far as square roots go, they are undone with a square. Remember, a square root and a square are just inverse functions of each other. So in the same manner that I would have x squared is equal to 144, then I can also have a square root of this is equal to what? Well, the square root undoes the square. So I get the square root of x squared would just be an x. And I'll talk about why that's the case in just a second. And then the square root of 144, well, we know that's equal to 12. Well, look at this, x squared and a square root. Well, a square root of x, I want you to see, is just x to the 1/2 power. It is a rational exponent. So if we have x squared to the 1/2 power, well, that's x. Remember, if you raise a power to another power, rules of exponents say that you're going to multiply those powers. So you end up with 2 over 2, which is just x to the first power, which is just x. So again, not a problem, okay? What happens with the square root? Well, just like we undid the square with a square root, I can do the same with this, okay? I can take this square root of x and I can undo that with a square. And here we just square both sides of the equation. And remember, this is x to the 1/2 squared. And in like manner as over here, we have x to the 1/2 squared is x to the 2 over 2, which is just x. And here we know 12 squared is equal to 144. And that is the solution to our equation. Okay? So again, it's straightforward. But there are steps you take. We said just a while ago, you have to isolate the square root. In this case, the square root was already isolated. So let's look at one where it's not, okay? And you'll see what I mean. So let's go to our next page, and we'll look at example 2. And we should have, we'll do something similar. We'll say square root of x times 2 is equal to let's say 6. Okay? So here, I don't have the radical on one side of the equation by itself. Okay? So what we're going to do is we're going to divide both sides by 2. Okay? And here we get 2 divided by 2 is 1 times the square root of x. It's just square root of x. And 6 divided by 2 is equal to 3. Now, I can just simply square both sides. So I get square root of x squared is equal to 3 squared. And remember we said the square undoes the radical. So that just becomes x equal to 3 squared is just 3 times 3, which is 9. Remember, we do not multiply the base and the exponent. So this isn't 3 times 2 is 6. This, if you recall, is 3 times 3. I take 2 of my bases according to the exponent and I multiply them. Okay? So we end up with x is equal to 9. And again, I can plug this in. Square root of 9 is 3 times 2 is indeed equal to 6. Okay? So let's look at another one similar to this. Example 3. And let's say I have the square root of x minus 5 is equal to, let's say 6. Okay? So we have the square root of x minus 5 is equal to 6. And same as before, my radical is not isolated. I have this minus 5 I have to deal with. So we want to add 5 to both sides of this equation first. And we're going to end up with the square root of x is equal to, because this 5 minus 5 is 0, and 6 plus 5 is 11. Now we have our radical on one side of the equation by itself. So all we have to do is square both sides to undo the radical. So we're going to take the square root of x and square it. And then we also have to do the same thing on the right-hand side. So we're going to square that 11 as well. So this square root of x squared is just x. And 11 squared, if you remember your multiplication tables, is 121. And that is your solution. Can I check it? Yes, you can. If I substitute 121 into square root of x, then square root of 121 is 11. And 11 minus 5 is 6. So I'll get 6 equal to 6. And again, you don't always have to write out your check. Sometimes you can just do mental math for that, which is what I've just done. Okay? So let's look at our next example. So we will have example 4. Okay, so example 4 says I have the square root of x plus 3 minus 7 is equal to 10. Okay? So on this problem, again, I have a little bit more under my radical, but that doesn't change what we do to the problem. Even though this looks a little more complicated, it is actually the same basic problem that we just did. Okay? We're going to get rid of this 7 to isolate the radical. Remember, it's about procedure. We want to isolate the radical on one side of the equation by itself, and then I can square both sides to undo the radical. So we're going to do that here. We're going to say plus 7 and plus 7, and that goes to 0. So we end up on the left-hand side with the square root of x plus 3. And on the right-hand side, 10 plus 7 is 17. And now I simply square both sides. And what is 17 squared? Well, I'll come off to the side here. 7 times 7 is 9, carry the 4. That's 119. 0, and that's 17, so we get 289. Okay, so if we square the square root of x plus 3, we end up with what's under the radical, which is just the x plus 3. And 17 squared we found to be 289. And then right here, I just want to subtract 3 from both sides, and that will give me x by itself, because 3 minus 3 is just 0. And we end up with x is equal to 286. Okay. Now on this one, if you want to pull up your calculator, you can do so. So we'll do that here. And we're going to take this 286. We're going to add 3 to it and get 289. Then we're going to square root that, which is right here. And then minus 7 is equal to 10. So again, x equals 286 is a valid solution. Okay? So that works good. So now let's look at another problem. Moving on, we're going to look at example 5. Now example 5, we're going to say the square root of x plus 4 is equal to x minus, we'll say 3. Okay? So on this one, guys, we have a variable on both sides of the equation. We also have an x plus 4 under the radical, and this radical is isolated. It's on one side of the equation by itself. So now our next step is to square both sides. And I hope you see where this is going. Because if I square the right-hand side, I end up with a quadratic. Okay? So right here we're going to say the square root of x plus 4. That whole quantity squared just gives me what's under the radical, which is x plus 4. And here, if I square this binomial, then we get x squared. And then I take the product, which is negative 3x times 2 is a negative 6x. And then negative 3 squared, and square the negative also. Negative 3 times negative 3 is a positive 9. Now I want to get everything to one side of the equation. Why? Because when you solve a quadratic, you need to get everything equal to 0. Okay? So what we're going to do is we're going to subtract x from both sides, and we're going to subtract 4 from both sides. And to save rewriting, I'm just going to transpose the terms, which means I'm going to move them across the equal sign and change the sign. So this x becomes a negative x on the other side of the equation. This plus 4 becomes a minus 4 on the other side of the equation. And let's switch our pen color back, and we'll end up with 0 is equal to x squared. Minus 6x minus x is a minus 7x. And this 9 minus 4 is just equal to a plus 5. So now we have a quadratic that we can solve. If you look at it, this 5 is not going to have any factors that are going to multiply to 5 and add to a negative 7. So we're going to have to use the quadratic formula. You could use other methods like complete the square, but in this case, we're just going to do the quadratic formula. Okay? So we need to isolate or identify our A, B, and C. So here, and I'm going to switch colors for this portion. We're going to say our A is equal to 1, our B is equal to a negative 7, and our C is equal to 5. All right? And I'm going to scroll down a little bit so that we can do this proper. And we're going to say our X is equal to opposite B plus or minus the square root of B squared minus 4AC and all of that is over 2a. And now we just want to substitute our a, b, and c into the quadratic formula and find our x values. And again, once we find them, we still have to check them because we may have an extraneous solution. So let's try this. We have a opposite b. When I substitute, I always want to use parentheses because I don't want to confuse the negative of my b with the negative in the formula. So this is opposite of a negative 7, and then this is plus or minus the square root of b squared. Again, that negative gets squared also, so another good reason to use parentheses, because without the parentheses, if you punch this on your calculator and you say negative 7 squared without the parentheses, you're going to end up with a negative number, and that's not going to give you the correct answer. So now we have a minus 4 times a, which is 1, and times c, which is 5. And all of this is over 2 times a, which is 1. So right now, we end up with opposite of negative 7 is a positive 7, plus or minus the square root of negative 7 squared is a positive 49 minus 20. And all of this is over 2. Okay? So now we end up with x is equal to 7 plus or minus the square root of 29 over 2. So that's our x values. Now, if you look at this, 29 I can't simplify. 29 is a prime number, so it has no perfect squares in it, so I can't simplify that radical. So this is our final solution for x, and we need to check these and make sure they both work. So we need to substitute these back into our original equation and see what we get, okay? To make this hopefully a little bit easier, we're going to substitute in on the right-hand side. The reason being is if I end up with a negative number on the right-hand side, and I look at this over here, I hope you guys are seeing this. This radical is not negative. It should be a positive number. So if I end up with a negative on the right-hand side, that's going to tell me that that solution of x is an extraneous solution, and we're going to toss it. It will not be a valid solution to this equation. Okay? So what we want to do is look at this, and I'm going to look at my two x values first. Because if you look up here, I have x minus 3. If my x value is negative, then I most definitely end up with a negative value on the right-hand side. So let's see what we end up with for our x values. I can tell you that x sub 1, our first x value, is 7 plus the square root of 29 divided by 2. Okay? Now, if you look at this, 7 over 2 is 3.5. So 3.5 plus some more is going to be bigger than 3. Okay? And a number bigger than 3 minus 3 is certainly positive. So I'm thinking x sub 1 is probably going to be our valid solution. Or our x sub 2 is equal to 7 minus the square root of 29 divided by 2. And if you look at this, 7 minus the square root of 29, we know the square root of 25 is 5. And we knew the square root of 36 is equal to 6. Well, this is close, so this is probably like a 5.3, 5.4, somewhere in there, and 7 minus that. So this could be a valid solution as well, okay? So we're going to check both of these. We're actually going to substitute both in and see what we get, all right? So if we come down here, we're going to rewrite our original equation. Square root of x plus 4 equals x minus 3. So we're going to have the check of our solutions. Square root of x plus 4 equals x minus 3. So I'm going to plug in the square root of 7 plus the square root of 29 divided by 2 plus 4, and all that's under the radical, and this is 7 plus square root of 29 over 2 minus 3. And we want to check that, but I'm going to go ahead and write out my other one, and then we can check this in a moment. So let's write out our second one. This is for x of 1, and our check for x of 2 is going to be similar, but we'll have a 7 minus square root of 29 divided by 2 plus 4. I'm sorry I wrote that so sloppy. And this is 7 minus the square root of 29. All of that over 2 minus 3. All right, and we will see if both of these check. Okay. So one way to do this is maybe go to a browser and go to Desmos. Desmos will allow you to type these radicals in pretty easily. So let's do that, and that'll give us an easy way to check. So I'm going to open up my browser here. And we're going to go to Desmos. And I'm going to show you a little trick also. So we're going to start graphing. All right. And let's see if I can do A equals. Okay. We're going to define a variable. And we're going to say A is equal to 5. Or, I'm sorry, 4. Does that work? Yeah, it looks like it. So what I can do is I can say x sub 1 is equal to 7 plus SQRT will give us a square root of 29. And then all of that, which I'm going to have to put in parentheses. I forgot about that. Because if I divide by 2, it's not going to give me the right answer. So there's our first x sub 1. And then I'm going to do x sub 2 is equal to, and I can copy this right here and paste it right here. Another good reason to use Desmos, you don't have to retype this twice. And that's 7 minus the square root of 29. And you see, indeed, that was a positive value. So now all I have to do to check this is come down here and look at f. We're going to do the left-hand side and the right-hand side. F of x is equal to the square root of x plus 4. And then g of x, I'm going to say, is equal to x minus 3. Okay? So is that the case? And we're going to look at this. And we're going to do f of x sub 1 and f of x sub 2. And make sure both sides are equal. So let's do f of x1. And we're going to do g of x1. And we get both sides equal. So our x sub 1 is indeed a valid solution. But let's check the other. F of x sub 2, I get 2.19. And g of x sub 2, g of x sub 2, we end up with a negative value. Yeah, I must have done that in my head wrong a while ago. Most definitely. I guess it was that top value threw me off. But yeah, we end up with a negative 2.19. Okay. So even though I thought both of these might be correct, and I even thought x sub 2, the right-hand side of the equation was looking positive, that wasn't the case. So sometimes our mental math, we can mess up. So always, always, always check your solutions, okay? Now, if you look at this, I've graphed the left-hand side of the equation, I graphed the right-hand side of the equation, and another approach is to do a graphical solution, and in this case, we do have a single intersection point at 6.193, which is what we got up here for x of 1. So that is our valid solution on this problem, 6.193, okay? So I can come over here and we can say that x of 2, this right here is not going to work. This is our extraneous solution. And our valid solution does work. So our solution to this problem is x equals 6.193. And I think that was the right value, yes. And since I rounded that, I should probably say approximately equal to, just to be more correct. Okay? So we have one more type of problem to look at. And that is a problem where we end up with two radicals in our problem. Okay, so let's look at that real quick. Okay, so our next example, which I forgot what example number we're on. We're on example 6 right now. So let's move this over here. And we're going to do example 6. Let's change our color. So example 6. And we're going to look at a problem with two radicals. So we're going to have square root of x plus 1 minus the square root of x is equal to 1. Okay? So let's see what we can do on this problem. I still want to follow the same procedure. I'm going to isolate one of the radicals, square both sides, and then we're going to move on and try and do the process again. So let's see what happens when we do that. So we're going to end up with the square root of x plus 1. I'm going to move this to the other side. So this is going to be equal to 1 plus the square root of x. Okay? And what we're going to do is we're going to try and square both sides. Okay? So I end up with what's under the radical because the square undoes the radical, and I end up with x plus 1. And right here I'm going to square this. So I get 1 squared is 1. Then I have 1 times the square root of x times 2, because there's 2 of them. So 2 times the square root of x. And then the square root of x times the square root of x, well, that's just x. So this is plus x. Now I want you to see what just happened. We now have x on both sides of the equation. We also have a 1 on each side of the equation. So what does that give us? Well, I end up with x goes out. This 1 goes out. So I'm left with 0 on the left-hand side is equal to 2 times the square root of x. And if I divide out the 2, I end up with 0 equals the square root of x. And squaring both sides will just give me x is equal to 0. So x equals 0 is our solution to this problem. Okay? So that one worked out simple. Okay? Nice, easy answer. But let's try another problem and see what happens on it. Okay? So we'll do one final example. And we'll do example 7. That's almost an E. And we're going to have, let's say, 3 times the square root of x plus 2 minus, we'll say 6 times the square root of x minus 4 is equal to, we'll say 12. Okay, so we got 3 times the square root of x plus 2 minus 6 times the square root of x minus 4 is equal to 12. And we want to solve this. So first of all, I notice I have 3 is a factor of everything. So the first thing I'm going to do is divide everything by 3. Okay? That'll help simplify things a bit. So the square root of x plus 2 minus 2 times the square root of x minus 4 is equal to 4. And I want to get everything to one side of the equation, not everything, everything but the first radical. This one I'm going to leave, and that's going to be the first one I solve for. So we're going to do the square root of x plus 2 is equal to, and if I move this to the other side, I end up with 4 plus 2 times the square root of x minus 4. Okay? And now I want to square both sides of the equation because now I have one of my radicals isolated on one side of the equation. So I'm going to square both sides. And remember, squaring this radical gives me what's under the radical, which is x plus 2. Here I have 4 times 4 is 16. Plus, this is 4 times 2 is 8 times square root of x minus 4 times 2, again, is going to be 16 times the square root of x minus 4. And then what's next? Well, if I square this, I end up with 2 squared is 4. And then this square root of x minus 4 times square root of x minus 4, well, that's just x minus 4. Okay? So what do we end up with here? We end up with x plus 2 is equal to 16 plus 16 times the square root of x minus 4. And this is plus 4x if we use distributive property right here. And then 4 times negative 4 is minus 16. Well, notice this 16 minus 16, those cancel. And now I'm going to isolate this radical. So this 4x I'm going to move over. So I end up with x plus 2 minus 4x is equal to 16 times the square root of x minus 4. Okay? So now what do we do? Now I'm going to come over here and simplify x minus 4x. So I get 2 minus 3x is equal to 16 times the square root of x minus 4. And let's scroll up just a little bit. Okay. So to finish this out, I want to divide both sides by 16. Okay, so I get 2 minus 3x over 16 is equal to what? Well, 16 over 16 cancels, and I'm left with the radical square root of x minus 4. Remember, we said to undo the radical, we want to square both sides. It looks messy now because I have fractions. But again, we're not going to fret about that. We're just going to do what it says. We're going to square both sides. And the top of this, I'm going to end up with 4 minus 2 times negative 3 is negative 6 times 2 again is a negative 12x. And then negative 3x squared is a plus 9x squared. And 16 times 16, what is that equal to? Well, we're going to do 16 times 16. We get 6 carry your 3. So that's 96. So it looks like it's going to be 256 right here. Okay? And that's equal to x minus 4. Okay? So this is going to be interesting. Okay? And some of you may think, well, this is looking like it's going to be really difficult as far as using quadratic formula. But again, it doesn't have to be. Okay, yes, we're ending up with some interesting numbers, but that doesn't make it a hard problem. Okay, Remember, if we're going to add and subtract fractions, I have to have a common denominator. So to do that, I'm just going to take this and multiply by 256 over 256. Okay? I don't know if 9 has a factor that goes into this. So again, I'm not going to worry about that right now. But once I do this, I realize, hey, I can cancel out this 256. And I could have just looked at this as a cross multiplication. Okay, that would have got rid of my fraction. But right now I can, we'll just say multiply by 256 on both sides and cancel those, since I didn't see the cross multiplication right away. So again, nice recovery, right? So now I'm left with what's on top. 4 minus 12x plus 9x squared is equal to 256 times x, and then minus 4 times 256. And we're just going to pull up a calculator for that because I'm not sure. So 4 times 256 equals, so 1,024. Okay? So minus 1,024. I think that was right. Yes. Okay. Now, because it's a quadratic equation, we have to move everything to one side, set it equal to 0. So this 256 is coming to the left. The negative 1024 is coming to the left. All right. So once we move everything to the other side, we get 4 minus 12x plus 9x squared minus 256x plus 1024 is equal to 0. And I need to slide this up a bit. Okay. So I want the x squared terms first because when I go to pull my a, b, and c, I need to make sure they're in the correct order. So I have 9x squared. So if I want to mark that, yes, I've taken care of that one. Okay, I got my 9x squared. What else do I have? I have a negative 12x and a negative 256. So that's going to be a negative 268x. So that means I've taken care of my 12x and my 256x. And now I have one last sum, which is 1024 and 4, which is going to be 1028. So plus 1028 equal to 0. Okay. So right now we have a quadratic equation with everything set equal to 0, and I need to pull my a, b, and c. So we're going to have a is equal to 9, b equals negative 268, and c is equal to 1028. Okay? And again, guys, the numbers are nasty, yes, but guess what? It's still an easy problem. Okay? We're just doing what we need to do. I can even check first to see if I have real solutions or non-real solutions by looking at b squared minus 4ac, which, if you remember, that's our discriminant, and it tells us what type of solutions we're looking at. So let's look at b squared. That's negative 268 quantity squared minus 4 times 9 is a, and c is 1028. Okay? So let's see what we get here. We need our calculator, so let's pull that up. I'm going to clear this off, and we end up with negative 268 squared. I'm just going to say 268 squared. That'll be the same thing. So we get 71,824. So 71,824 minus, let's see what else we get. Minus 4 times 9 times 1028. And I want to see what that number is, so I'm going to say times 1. 37,008. So this is actually 37,008. And we get what? A little neat trick. We get 34,816. Okay, so 34,816. Okay. So now, what are we going to end up with? Hey students, technical difficulty. We interrupt this special programming for this little announcement. Apparently I hit the pause button and did not unpause the video, so the rest of this solution did not make it onto the video. I do apologize, but I hope you will take the time to finish out the solution. It is an interesting result. And if you're going to simplify the radical that shows up with that really large number, it does help to do a factor tree. Factor trees are really useful in pulling out the perfect squares in the number and being able to simplify the radicals. So anyways, please take time to do that. I will give you a hint. There is no solution to this problem. If you end up with your two x values and check those, neither of them works. So they are both extraneous solutions. So that's just how it works out. You can also show this graphically. If you will go into Desmos and graph both sides of the equation, you will find out that that is indeed the case. So anyways, I do apologize that you're not getting to see the rest of the solution, but again, I'll leave that to you. I do want to say in summary that when you're solving radical equations, you do want to isolate the radical on one side of the equation by itself. You are using squares to undo the radical. This can lead to quadratics, and you will need to solve. And the solutions that you get, you need to always check them, because you could end up with one solution where another solution is not valid, or we call it extraneous. I could end up with two solutions, or as in this last example we saw, there are no solutions. So always check to make sure you don't have any extraneous solutions for the x values that you get. So I hope you enjoyed the lesson today, and I hope you guys will have fun solving radical equations.